Something is wrong with the moon, not on it, behind it. For the past 6 months, NASA's Lunar Reconnaissance Orbiter has been detecting gravitational anomalies that don't match any known mascon or subsurface structure. The readings appear and disappear in a pattern that suggests movement. Not orbital drift, not solar wind effects. Movement with intention. On September 12, 2025, the anomaly crossed into direct line of sight from Earth for exactly 47 minutes during a lunar libration window. In that brief exposure, 3 independent observatories captured the same infrared signature. An object roughly 340 meters across, surface temperature 23 Kelvin colder than the surrounding void, and a spectral profile that matches no asteroid, no comet, and no piece of human-made debris ever launched. Then it vanished back behind the lunar far side. And it's still there, moving. The question isn't whether something massive is hiding behind the moon. The data confirms it. The question is what happens when it stops hiding. Because every orbit, it's getting closer to the edge. And NASA has gone silent. The first hint came from somewhere unexpected. Not from NASA, not from ESA, from the Chinese National Space Administration. On March 3, 2025, China's Queqiao-2 relay satellite, positioned at the Earth-Moon L2 Lagrange point, experienced a communication dropout lasting 4 minutes and 18 seconds. The official statement blamed solar interference, but amateur radio operators monitoring the deep space network frequencies caught something else. A telemetry spike, a sudden gravitational tug that briefly altered Queqiao-2's station-keeping burns by 0.14 meters per second. That's not interference. That's mass. Within 72 hours, NASA's Lunar Reconnaissance Orbiter began reporting similar anomalies. Its laser altimeter, designed to map the moon's surface to centimeter precision, started registering phantom returns. Reflections from empty space, 1,847 kilometers behind the moon. The LRO team ran diagnostics. Instrument failure, cosmic ray hits, software glitch. Every test came back clean. Then the gravity data arrived. LRO carries an ultra-sensitive accelerometer that measures the moon's gravitational field. It's how we discovered the mascons, those dense concentrations of mass beneath the lunar surface from ancient asteroid impacts. But this signal was different. It wasn't static. It wasn't buried. It moved. Between April and August 2025, the anomaly completed 3 full circuits around the moon's far side. Each orbit took approximately 41.3 days. The trajectory wasn't stable. It was spiraling inward, losing altitude at a rate of 220 meters per orbit. Whatever this object is, it's not in a natural parking orbit. It's descending. NASA's Artemis mission planners noticed immediately. Artemis 3, scheduled to land near the lunar South Pole in late 2026, would pass within 580 kilometers of the anomaly's projected path. Flight dynamics teams ran collision assessments. Probability of impact? Negligible. Probability of gravitational interference with descent trajectory? 0.03%. Small, but non-zero. That's when the data classification began. Internal memos leaked to spaceflight forums showed mission managers requesting a blackout on LRO gravity data. The reason given was operational security. The real reason, according to 3 sources within NASA's Goddard Space Flight Center, was that they didn't know what they were tracking, and admitting that publicly was worse than staying silent. But silence doesn't stop physics, and the anomaly kept moving. Lunar libration is a subtle wobble in the moon's rotation that lets us peek slightly beyond the far side edges. It's how we see 59% of the lunar surface from Earth instead of just 50. Most of the time, it reveals nothing more than a few extra craters. September 12th, 2025 was different. At 0314 UTC, the moon's libration reached a maximum tilt of 7.9 degrees, exposing a sliver of space normally hidden from Earth. The timing was perfect. 3 observatories were already watching. The Keck Observatory in Hawaii, the Very Large Telescope in Chile, and surprisingly, the Arecibo Successor Facility in Puerto Rico, rebuilt and operational ahead of schedule. The target coordinates were calculated in advance using LRO's gravity anomaly data. If something was there, it would cross into view for less than an hour. The infrared cameras were ready. At 3:31 UTC, Keck's NIRC-2 instrument locked on. The first frames showed nothing but background stars. Then, at 3:34, a cold spot appeared. Not a point source like a distant galaxy. An extended object, roughly circular, angular diameter of 0.41 arcseconds. Do the math. At the moon's distance of 384,400 kilometers, that translates to a physical size of approximately 340 meters. Larger than the International Space Station. Larger than any spacecraft ever built. Larger than most asteroids we track near Earth. But the temperature was wrong. Space around the moon hovers near 270 Kelvin, heated by sunlight and Earth's reflected glow. This object registered at 247 Kelvin, 23 degrees colder. That's not passive cooling. That's active thermal management, or a surface material with albedo and emissivity properties we've never seen before. The VLT in Chile captured the same signature 6 minutes later. Confirmation, not a glitch, not a sensor artifact. Real. Then came the spectrum. Infrared spectroscopy can identify materials by how they absorb and emit light at different wavelengths. Asteroids show silicate features. Comets show water ice and carbon dioxide. Human satellites show aluminum oxide and solar panel coatings. This showed none of that. The spectrum was nearly flat, featureless, as if the object was either perfectly black, absorbing everything, or covered in a material with no distinct chemical signature. One astronomer at Keck described it as a null result. Another called it a stealth spectrum. At 4:18 UTC, the libration window closed. The object slipped back behind the moon. All 3 observatories tried to track it. All 3 lost the signal within minutes. NASA issued no statement. ESA said nothing. China's CNSA remained silent, but the data was already spreading through the astronomy community. Private Slack channels, encrypted emails. By September 15th, every major observatory on Earth knew something was there, and no one knew what to do about it. Gravity doesn't lie, and the gravity signature of this object is breaking the rules. LRO's accelerometer measures tiny tugs, changes in velocity as small as 0.00001 meters per second. It's sensitive enough to detect the gravitational pull of a 1-meter boulder on the lunar surface from orbit. When it started registering anomalies in March, the first assumption was simple. A small, dense object, maybe an iron-nickel asteroid, temporarily captured by the moon's gravity before escaping back into solar orbit. But the numbers didn't fit. To produce the observed gravitational deflection of 0.14 meters per second on Queqiao-2 at a distance of 1,800 kilometers, you'd need an object with a mass of roughly 8.7 million kilograms. That's dense. Too dense for rock. Even solid iron would require a diameter of at least 150 meters to pack that much mass. The September observations measured the object at 340 meters across. If it were solid iron, the mass would be closer to 200 million kilograms. The gravity signature would be 15 times stronger. But it's not, which means one of 2 things. Either the object is mostly hollow, with an average density of just 430 kilograms per cubic meter, roughly the same as Jupiter's moon Amalthea, or the gravity measurements are wrong. Neither option makes sense. Natural objects don't form hollow spheres. Physics doesn't allow it. Asteroids are rubble piles, loosely bound rocks held together by weak gravity. They can be porous, sure, but not structured voids. And LRO's instruments aren't wrong. They've been calibrated against the moon's known maskins for over 15 years. The error bars are tight. So teams started looking for a third option. What if the object isn't generating the gravity anomaly through mass alone? What if it's moving in a way that creates apparent gravitational effects? Enter the Yarkovsky effect. It's a tiny force caused by sunlight heating one side of an asteroid and radiating away as infrared from the other. Over millions of years, it can shift orbits. But the effect is proportional to rotation and surface area. It's weak. Way too weak to explain what LRO is seeing. Then there's the ion drive hypothesis. If the object were an artificial probe using electric propulsion, the continuous low-thrust acceleration could mimic gravitational tugs. But ion drives produce plasma exhaust, detectable in ultraviolet and radio frequencies. NASA's stereo satellites and the Air Force's Space Surveillance Network found nothing. No exhaust plume, no electromagnetic signature. The orbital mechanics team at NASA's Jet Propulsion Laboratory ran a different simulation. What if the object wasn't accelerating itself? What if something else was accelerating it? A tether? A magnetic field interaction? A gravitational slingshot off a smaller, undetected companion object? All plausible, none confirmed.